Example 7. The annual interest rate on a credit card is 24.99%. If a payment of $100 is made each month, how long will it take to pay off a balance of $2,487.56? Assume that no new purchases are made with the credit card. Okay, this is another excellent question that you can find relatable to your everyday life. Okay, where you have a credit card balance and maybe you can only afford the minimum payment. Okay, here in this question, the minimum payment might be $100. Okay, how long is it going to take you to pay off your credit card if you just continually make that minimum payment? Okay. All right, so we are paying off a debt here. Okay. So obviously you would want to use the amortization formula here as you're paying off your credit card. The thing is, the question is, how long will it take? So we are solving for time. Okay. So what I'm going to do is, let me pull up my formula sheet here for a second. Okay. When you look at the amortization formula, okay, obviously it's complicated, but if you're solving for time, this is going to be ultra tricky because time is in the denominator, okay? So what I recommend that you do for a problem like this, remember I told you earlier that these two formulas are equivalent, okay? So the amortization formula is equivalent to the present value of an annuity formula, okay? So in this formula, T is in the numerator, okay? So I would use this formula instead because you're solving for time and it's in the numerator. It's a little bit easier to solve for because it's in the numerator as opposed to the denominator, okay? So these two formulas are equivalent. We're going to use this one. Remember, the only difference is that PV and D, they are the same thing. That's what you've got to remember if you're using these interchangeably. PV and D are the same thing, okay? So to solve this problem, I am going to write down the present value of an annuity formula, okay? All right, so we're going to use this. All right, so there we go, okay? So let's figure out what we're looking for. Well, we already know that. We're looking for time, okay? And we should know everything else, okay? So remember, okay, PV is equivalent to D, okay? The debt is how much you owe on your credit card, okay? So the PV, which is the debt, I'll even put that here, okay, is this $2,487.56, okay? That's the PV, okay? Think about it as how much you currently owe or presently owe, okay? The p-value, that's going to be the payment you're going to make. You're making regular payments of $100, okay? The interest rate is very high, 0.2499. Like I said, that is a very realistic interest rate for things like furniture, clothing, okay? Very realistic. Let's see here. And what else do we need? Okay, so we are making payments every month. That's going to coincide with how often the interest is compounded on the unpaid balance. So we're going to go ahead and write that is 12. Okay, so let's go ahead and plug all of this in, and then we will start solving for T. Okay, so give me a minute to plug all of this in. All right, so here we go. All right, okay, so we've got to solve this for T, okay, and we know that can be complicated for sure, okay. T is in the exponent, okay, so you're going to have to get it out of the exponent, okay, so you're going to have to isolate this thing, okay, because that stuff in parentheses, that is what's being raised to the negative 12t power, okay. So you're going to have to isolate that guy, and then once it's isolated, you're going to have to involve a logarithm, Okay, so let's walk through the steps step by step about how we would do this. Okay, first thing of doing this isolation of this thing in pink. Okay, this 100 is outside of the brackets, so I'm going to go ahead, since we're taking 100 and we're multiplying by this quantity. To undo that, we're going to divide both sides by 100. Okay, so go ahead and, pop that in the calculator. All right, this is going to give us, oops, I'm very bad at hitting my camera all the time. Okay, so that's going to give us 24.8756. You have to bring all the digits, okay? You cannot round until the very end, okay? So over here, the 100s are going to cancel, and it's just going to leave you with the stuff inside the brackets. All right. All right, next step. Okay, again, you are still after isolating this piece. Okay. All right, so this fraction on the right, okay, we are dividing by r over m. Okay, so to undo that, we're going to multiply by r over m, okay, because that's the opposite. Okay, so instead of dividing by r over m, we're going to multiply by it. Okay, whatever you do to one side, you have to do to the other side. Okay, so on the right side, okay, you have r over m in the bottom. That will cancel with r over m in the top. Okay, it is going to leave you with the numerator only. Okay, on the right, you can go ahead and start putting this in the calculator. Okay, that's what I would do. Okay, this is kind of a lengthy process, so I would just keep up with the calculator calculations. Okay, so let's see, we're going to have, oops, let's do it this way. All right, we're going to have this 24.8756 times r over m. Okay, so this is what is on the left side. I'm going to go ahead and write that entire decimal expansion here. Okay. All right, so there we are. Okay. Again, we are still after isolating this guy. Okay, so you've got this 1 hanging around in front. Okay, this 1 is positive. It's positive 1 minus this stuff. Okay, so it's kind of like you're adding 1 because it's positive. So to undo that, you're going to subtract 1, okay, from both sides. Okay, on the right, you're going to be left with this negative sign is still going to be there. Okay, still out front, in front of the parentheses. Okay, so it's going to look like this. All right, go back to your calculator. Okay, we're going to hit this guy, what we had, minus 1. Okay, so we need to write this down on the left side. Okay, very lengthy process to do this problem. Okay, all right, so we're almost there. You want this guy. Okay, there is a negative in front. Okay, you've got to get rid of it. Okay, we know that eventually we're going to have to take the logarithm, okay, to get the t out of the exponent. Okay, you cannot take the, I don't know how much experience you have with logarithms, but you cannot take the logarithm of something negative. So you have to remove that negative sign before you can take the logarithm. Okay, so what we're going to do is just divide both sides or multiply both sides by -1. Okay, so that's going to give us this. And now this quantity is isolated. Okay. All right. So let me get another sheet of paper so we can continue with this problem. Okay. All right. So give me a second to rewrite this. Oops. All right. Okay, so what we have, let me write down what we have. Okay, we have managed to isolate this quantity, which is great. All right, so here we go. Since this thing is isolated now, okay, the t is in the exponent. This is an exponential equation, okay? To bring that t out of the exponent, we have to involve a logarithm. So I told you in this class, we're only going to use natural log, okay? So we're going to take the natural log of both sides, okay? Remember, natural log goes on the left. It does not make sense on the right, okay? So take the natural log of both sides. Whatever you do to one side, you have to do to the other, okay? All right, and now, like I've told you on other occasions when we've solved these things for time, okay, if you have the logarithm of something to a power, you are allowed to bring that power down in front, okay? You can only bring that power down in front after you've taken the logarithm, okay? So the left side will not change, okay? We're going to bring down the power, so it's going to be negative 12t times this other logarithm, okay? All right, there's no more power up here because you brought it down, okay? All right, so what we're going to do, remember when we solve for time, we're not actually solving for t, we're solving for ilm times t, so we need to solve for 12t, okay? All right, so what I'm going to do is this logarithm right here, when you punch this into the calculator, this is going to be some nasty decimal, okay? It's just a number, okay? I am going to divide both sides by this number because I'm trying to isolate the 12t. Okay, so let's divide this off. Whatever you do to one side, you have to do to the other. All right, so on the right side, what's going to happen is that these guys will cancel. You're actually going to be left with negative 12t, okay, because we haven't done anything with this negative sign yet, okay? I am going to go to my calculator, and I am going to punch this guy in, okay? All right, look where we left off on our calculator. This is where we left off, okay? We have that 0.48 decimal, but it's negative. So I'm going to go ahead and multiply or divide this by -1, okay, to make it positive, okay? And now I'm going to take the natural log of that quantity, okay? Again, you could type in the decimals if you wanted to, okay? You have to use the whole decimal expansion here, okay? All right, so you're going to take the logarithm. This is the logarithm of this is the numerator, okay? So now we're going to divide that by the natural log of 1 plus 0.2499 divided by 12, okay? This is going to give us the quantity on the left side. It's going to give us this calculation, okay? So here we go. This is what you should get, okay? So I'm going to go ahead and write that down for you, okay? All right, so we get negative 35.41206,573. Okay, so that is what's equal to negative 12t, okay? Notice both sides are negative, okay, which is good, okay? We're solving for time. You don't want a negative time value, okay? So if you had gotten to this point and one side is negative and one side is positive, that's going to imply that you're going to end up with a negative time value, which is bad, okay? So you've done something wrong. But because both sides are negative, now we can just divide both sides by -1, okay? And now both sides are positive, so we're going to get a positive time value, okay? All right, so this is where we stop. This is what we've done in the past. You don't go a step further and divide by 12. You don't do that. You stop and interpret your answer. Because there's a 12 in front of t and there's 12 months in a year, this is going to be telling you, this is indicating the number of months that it's going to take to pay off your credit card debt, okay? And remember, the other thing we've always done when we're solving for time like this is that we round up to ensure we have enough time, okay? So you take this number, okay, even though it's 35.4 and that would normally round to 35, you bump it up to the next whole number to ensure that you have enough time to pay off your credit card debt. So we're going to bump this up to an even 36, okay, is equal to 12t. Okay, so again, this is indicating the number of months. Okay, so the answer is it will take 36 months, which is the same thing as 3 years, to pay off this credit card debt. Okay.